Hello everyone, in this tutorial I will show you how to extract this tessellation algorithm from the Unreal Engine water system. You can use this tessellation in Unreal Engine 5 to optimize your ocean water plane or your terrain. A mesh tile has a smooth transition between level of detail, morphing into and out of one another with the camera distance. To achieve this, we need to create a custom mesh component using custom vertex factory. And at the end of our tutorial, I will show you how to add this tessellation to our custom ocean simulation. First, we need to create a new folder to place this new project. Name it Unreal Project. You can choose anywhere that you want to place the project and open Epic Game Launcher and go to Library. I use Unreal Engine 5.3 for this project and launch this. Then choose game and can choose this third person. C++ project and the location. Copy this location. And paste it. The name of project is custom project. Let's create. Let's create a new map. Level and name is new map. And we can copy all this lighting. Control C and go to this new map. Paste this lighting. And here is a new empty map. Set this as the default map. Go to project setting. And map and mode. Search for new map. And use this new map in the game default map. And let's save this. And we need to create a new plugin because we want to place this tessellation algorithm inside this new plugin. And choose blank plugin. The plugin name is Custom Water. And we can set this to its beta version because it is not the complete plugin, so create it. After you create this plugin, you can close the project and you can reload this Visual Studio. And inside your game project, you can see this plugin, and it is Custom Water. Next step, we need to find our water system plugin location. We find your Unreal Engine install location, Unreal Engine 5.3. Go to Engine, source code, go to plugins, experimental, and you can see this water. Copy this and you can place it here. Too easy to access this file. Open the source and go to runtime. And we will copy the file that related to the tessellation. So we need water instance data buffer.h, water mesh component, water scene proxy, water module, water quad 3, and water util, water vertex factory .h and .inl. Copy this, open this project, go to our custom project, go to plugin, to source, custom water, pass it inside this public location, and delete this custom water.h, also this custom water.cpp file. Go to this private, we copy this water mesh component, water mesh scene proxy, water module, water quad 3, water util, and water vertex factory. Copy this and back to our custom water that we create. Go to private and pass this. And let's add a new text document. Name this to water mesh actor .h and click yes. And this water mesh actor .cpp and click yes. Now delete this .vs. We can delete because we still open the project inside Visual Studio. So close this first and delete. Delete this intermediate file, save, and delete this. And we generate Visual Studio project files again. So after generate it, open custom project.sln and open this plugin and source. So you can see all these files that we add is inside this plugin source. We can close this. But inside our water source code, we need this shader. You can see this private, and we use this water mesh vertex factory.ush. And back to our plugin of our project, custom project. Add new file. Name is shaders. And new file inside this shaders. Name is private. And open this private file. Let's copy this water mesh vertex factory.ush and pass it here. Open this Visual Studio again. Open this custom water.u plugin and this loading phase. It is default. Set it to host config init and save this. Open custom water build.cs, and we need to add the dependency module name and the private include path to this. Open water plugin and go to source code. Open this water build.cs, and we want to copy this and pass it inside custom water build.cs. Some dependency module we done it, but I want to keep it simple, so just copy this, all of it. And let's set this. We can close this water build.cs. And let's set this name to custom water class. Everything is correct. Let's save. We need to fix our file that we just copied to support our custom water plugin. We can open this water vertex factory. Wait for the Visual Studio to find the error, and we don't have any error. Open this water util, and we get some error here. It's caused by this API name is different. We should use custom water API. Change it to custom water API for all of these names. And save. Next is our water module. This one is custom water API. And this with editor. And we don't have to include water editor service. Delete this and save. And let's go to water module.cpp. This class, we change the name to F custom water module. And this plugin is custom water, and the shader plugin custom water. This startup module, it set the location of the directory of the shader of our WaterMesh vertex factory.ush. And implement module F custom module. And this one is custom water. Let's save this. Write some code for our water mesh actor.h. So we add pragma 1, include for minimal .h, or with e, and include game framework class actor.h, include watermesh component.h, and include watermesh actor dot generated.h. Because this is the actor class, we create new class. And the class custom water API. A water mesh actor, public actor. Generated body. Public. And a water mesh actor. Cons F object initializer. This will set the default value for this actor property for this function. And let's protect virtual void begin play. Just like in blueprint, we have the begin play override and public virtual void tick. This tick will call every frame with delta time. Override. Save this. Open WaterMesh actor.cpp. Include WaterMesh actor.h. And another include waterutil.h. I include this waterutil.h because we will use it later. WaterMesh actor and a WaterMesh actor cons F object initializer and initializer. Super initializer. Primary actor tick dot b can ever tick equal to true. Everything is red because we not yet generate this WaterMesh actor generated.h. After we rebuild, we will get rid of this error. Let's call void a WaterMesh actor begin play. Super begin play. Void a WaterMesh actor tick load delta time super tick delta time. This actor is capital letter. Sorry, this is a actor. This, why I type it wrong? This is actor. It's correct. Let's close this and open the project. Clean this. Then delete this config. Delete this derive. Intermediate. Save. And generate Visual Studio project file. Open this .sln. Open your WaterMesh actor.h and WaterMesh actor.cpp. Save. Now we don't have any error. But if you still have the error, it might caused by your Visual Studio not set up correctly. It will not cause any problem with your compiling, but it's hard for you to work with your project. Can install this Visual Studio integration tool inside this plugin. And you can enable this editor symbol for debugging, and you can hit apply. It might take a while to download this, but it's help you to work with your project in C++. Let's go to WaterMesh component.h and we change this class API, custom water API. And let's save this. Under this public function, we'll add another variable enum and class water body type u in 8. First is river, lake, ocean, transition, u meta, display name equal to custom, and num u meta hidden, because this system we use from water system, so we include this in open WaterMesh component.cpp. We don't need this water body component, and we don't use the spline subsystem. We can include WaterMesh actor, that is our own actor that we just create. Continue to fix the errors. We have some error with a water zone because we don't have the water zone. Delete all of this and return true. And we have a lot of error inside this rebuild water mesh. So we delete all this code. This rebuild water mesh in the original system, we rebuild water mesh depend on the type of the water, like lake, river, or ocean, or custom. But we don't need this. We need only a simple plane, so we can delete all of it. Let's save. Open water vertex factory.h, water vertex factory.cpp, and this plugin set the water mesh vertex factory. The location is this custom water, not the water. Change this to custom water and save this. Let's run this project, see if we have any error. We get the error that we missing the module. The engine asks us to rebuild them. And you can see this error. You can set this to build only, to only show the error for the build. And this unresolved external symbol class T auto console variable C var water enable. So we need to add this C var water enable variable and set no. Go to watermesh component.cpp. This we have T auto console variable. Under this, we add another one. T auto console variable in 32. C var water mesh, not mesh, water enable. X or dot water dot enable set it to 1. X is water ECVF render thread safe. And if you don't have this water mesh enable, you can add this too. Save. Let's run this again. Now we can open the project without any error. And you can see inside this plugin, we have the custom water plugin. Inside this, we have this water mesh actor and water mesh component. Let's go to plugin and we can search for custom water. And this is our custom water. Can disable or enable it. That is correct. We can close this. Get some input from our water mesh actor. Inside this public, we add some variable, U property, visible anywhere, category, wall to water, blueprint, read only. Variable type is UWaterMesh component. and water mesh. Next is view property. Edit anywhere. Category equal rendering. Key object pointer. View material interface. Water material. And we can copy this view property, paste it here. Key object pointer, view material instant dynamic. Or MID. MID is shortcut for material instant dynamic. We change this. Category equal to debug. And visible instance only. Transient. NumPy duplicate transient. Text export transient. Meta display after equal water material. Add another visual white post load sub object app object instancing graph. Outer instant graph and override. View function blueprint callable. Category equal rendering. We type the function wrong. C. We receive view material instant dynamic. Get water material instant. View function blueprint callable. Category for rendering. Void create or update water MID. E object flex get transient MID flex on and save this. Open WaterMesh actor.cpp. For a WaterMesh actor function, we create a WaterMesh equal to create default sub-object. Use WaterMesh component. WaterMesh Then set root component to water mesh. We create this water mesh and then set it to the root component. And before the tick, call void a water mesh actor host load sub objects f object instancing graph. Outer instant graph. In water mesh, detach from component. F detachment transform rule. Keep word transform and super host load sub object. Outer instant graph. Event tick we call if we have water mesh update. We update the LOD and all the variable of the water mesh. And another the new function U material instance dynamic. A water mesh actor get water material instance and create or update water MID. Return water MID. Void. We use void when the function don't have any return. Water mesh actor create or update water MID. And if get word if is small letter water MID equal F water utils get or create transient MID water MID text water MID water material get transient MID flex. A object flex a water mesh actor get transient MID flex ons and return or F transient and or F NumPy duplicate transient or F export transient. And let's save this. Here you can set this water material for our water mesh. Go to water mesh component, and we need to write some code for this rebuild water mesh. We create a new variable is water mesh height and get component location a actor and get owner a actor. We use a actor instead of water zone because we found this water mesh inside this water mesh actor.cpp. A water mesh actor equal to hash to a water mesh actor, and for this actor f water body render data we send this render data inside this water quad tree. So this quad tree will store our data for the render. Cons e water body type equal to e water body type ocean. And we assign material instance. U material instant dynamic. Water material equal water mesh actor and get water material instant. Render data material equal to water material. If we have render data material, if this material isn't used for the water, we set render data material equal to U material get default material. MD surface. So if this material is not used with the water, we have to set it to default material. And we can set this too. And set the use material at this render data material. Use material with S. Delete this and min and max user define priority range. You need to set all these variables because it have inside this water quad3. So if you go inside this water quad3, you can see this. We have material, surface base height, and the priority, water body index, water body type. So we have to set all of these variables. Cons in 32 min priority equal to minus 8192. Cons in 32 max priority equal to 8191. Render data priority equal to 1. Render data dot water body index equal to 1. Render data dot surface base height equal to hectare height. We get hectare location and get the Z value of this hectare. And render data water body type equal to static has in a water body type. Our water body type is ocean. If with water selection support, render data dot heat proxy equal to new h hectare and null pointer, and render data dot b water body selected equal to hectare and call is selected. Add if u in 32 water body render data index equal to water quad3 call add water body render data. We add this render data. Next, we trace CPU profiler event scope ocean. We need to create a polygon, and this polygon we use it to create the ocean bound. Here F vector 2D, polygon. Because in this water system, we have the spline to control where is the island of the water, but we only need the plane, so we need to just create a polygon without the spline. Array F vector polyline vertices F box ocean bound float plane scale equal to R size multiply by 2 divided by 100. Then we define the vertices of a square, just a simple square. F vector vertex 1 minus plane scale for x minus plane scale for y. The z is 0. You can copy this. The square we have 4 vertices, so pass it 4 times. Vertex 2, 3, and 4. This we delete the minus value, this 5, and it is positive on x and y for vertex 4. Then add this vertex to the polyline vertices array. Add vertex 1. Copy and pass it 4 times. Vertex 2, vertex 3, and vertex 4. The recall for loop cons F vector reference vertex and polyline vertices. We get only the x and y axis, so it is on the flat plane. F vector 2D vertex 2D vertex x and vertex y. Polygon dot add vertex 2D. And then we calculate bounding box. F vector min extent equal to F vector FLT max. FLT max and FLT max. F vector max extent equal to F vector, copy this and pass it here, set it to minus. And for each loop, cons F vector reference of name it vertex of the polyline vertices min extend x equal to f math min extend dot x vertex x and copy as min extend y, and we use this as min extend y vertex y, and this one is z. And we can copy this as it here, change min to make extend, and this is make. And then we get this ocean bound for to f box of min extend and make extend. We create the box from the value of this polygon. Then water 3 add water house inside bound, ocean bounds, water body, render data index, semicolon for the file mesh, I create float, name is make value high, set it to 10, file mesh high equal to render data surface base high, subtract with this make value high, and water quad 3 dot unlock true. Mark render state dirty. Let's save this and run. So this function will rebuild everything. This water mesh. We can adjust the tile size. We get this error because when I delete the function, I accidentally delete the update function. So we need to create this update back of this water mesh component. Go to water plugin, we copy it here, and go to editor, editor runtime, private, and water mesh component.cpp. Scroll down, and you can see this update function. Copy all this update and pass it to our water mesh component. Pass it under the RebuildWaterMesh function. And let's save this. Now you can close this. Let's run. We can open this project. Go to C++, go to plugin and this custom water public. Drag this water mesh actor inside this and set its location to 0. First, press F. And let's try to play this. We don't want to spawn the third person character. So go to Window. Go to Window and go to World Setting. Set this game mode override to game mode. Because we will spawn a floating pound actor instead of third person character. Let's play. It won't spawn anything. Go to content and create a new material. This happened because we don't have the material inside the water mesh actor. So let's create a new material, red. Open the material. Press 3 and click and set it to red color. Make sure that your material have this use with water enable this, set it to true. Apply and save. Go to water mesh actor, detail, and set this water material. Let's play test. And now we spawn water mesh, but we have the default material, not the red material. This happened because our code is having some problem. Stop this. This render data material, we set it to the default material. We should set this before this water material. And delete this. Let's play again. Drag this water mesh actor to our scene. Set it to 0. And set the red color material to this water material. And let's play test. Now we have the red color. This is the water mesh. And you can go to this water meshing system and surface rendering of Unreal Engine documentary. You can see this tessellation. And we copy this console command. water.all.water.watermesh.show wireframe 1. Pass it to this enter console command and enter. Here you can see this tessellation, the wireframe of the vertices. It changed the vertices amount according to the distance from the camera. And you can go to water mesh actor, set this tessellation factor down or up. So let's set it to 4. And when we go up, this tessellation will change the level of detail. And this is the lowest level of detail. It's 2 by 2 square. You can go to this water mesh and change the tile size of this plane. And the amount of tessellation factor. If you set it too high, it will affect your performance. Next, we will look into the file mesh of the water mesh. Go to waterquad3.h and scroll down, find the function of file mesh. Add file mesh. And we want more control for this file mesh. So we will modify this function. Add another input, double, in center mesh, extend, and save this. Open waterquad 3 and go to this error. Double in center mesh, extend. And then we copy this outpost and pass it. Comment on the first one. And we use water center. Add with 0.5, 0.5, add with 0.5, divide by in center mesh, extend. And we multiply with the infime distance mesh, extend. Then multiply by 2. After that, this scale, we copy this scale, select all this, comment on it, Ctrl K, Ctrl C. And we use only infime distance mesh, extend. And multiply by 2. Save this. Go to watermesh component.h. Find the variable of the file mesh. This one, use file mesh without ocean. We just delete this without ocean and save. Go to public variable and you can see this file mesh distance extend, set it to 2400, the same as this file size. And we copy this U property, create a new variable, name is float center mesh extend equal to 1.0 f. This f is for the float value. the cell, and you can copy this variable name RebuildWaterMesh component.cpp. This is the error because we changed this name to use file mesh without ocean. We change it to be use file mesh. And copy this and paste it again. The name is center mesh extend. Let's save this. Next, we need to call add file mesh function inside the RebuildWaterMesh function. After we add water tile inside bound of the water quantity, where the file distance mesh instance if needed. If we use file mesh is true and is material used with water fire distance material. We check that if this fire distance material is used with water material, and fire distance mesh extend greater than 0. Use material dot add fire distance material. Material with S and water 3 dot add fire mesh. Fire distance material. Fire distance mesh extend. Fire mesh high. And center mesh extend. And save this. Let's run. Make sure to save all and run again. We don't have any problem when we run again. Duplicate this material and rename it to green. And we can open this material and set it to two sides to display the top and the bottom. This green, set to side. Set this color to green color. Okay. Apply. Don't forget to set this use with water to true. If you don't set it, it will not work. And go to plugin, add this water mesh actor, set it to 0. This system, you need to set it to 0. If you set it to other location, it might not work. And water material, M red. This fire distance, set this M green. material and use file mesh, set it to true. Let's play. And here you can see the center is the tessellation mesh and the outside is the file mesh. And if you go down, you can see it, the center don't have the file mesh. And the file mesh is slightly under this water mesh a little bit to avoid these two meshes overlap each other. And you can scale this far distance mesh if you want this far distance mesh to larger surface. That multiply it by 10. First multiply this extent by 10 and multiply this center mesh extent by 10 too. Here you can see it's larger than 10 times and this center is working correctly. And you can scale this center, the red one. You can multiply it with 2 and this file mesh will not cut this mesh correctly, so you need to multiply it with 2 too for the file mesh. And this center mesh extend. Let's check again if our tessellation is working. Or WaterMesh dot show wireframe and space and 1. And you can see the center have the tessellation and the file mesh is the low poly mesh. That's it for our tessellation system. You can close it and close. If you want to use this tessellation for other project, you can just copy this plugin and then you can generate Visual Studio project file and you will get this tessellation. We will use our tessellation, add it to our ocean simulation. If you don't have this ocean simulation, you can go to the previous tutorial of this series, or you can download it from my Patreon page. Find our ocean tutorial project, copy and paste it here. You can delete this water plugin because we already use it. Open this ocean tutorial.sln and open ocean tutorial.u project. Set this water plugin to false, or you can delete this water plugin and delete this water because our custom water will have the same file name as this water plugin, so it will conflict with each other and create error that we can't open the project. So we need to disable this water plugin. Let's save. And ocean tutorial build.cs. Delete this water save, and we can close this. Let's open our custom project and copy the plugin and pass it here. Go inside this plugin and delete binary and intermediate. Delete .ps binary, derived data cache, intermediate, save, .vs config, .sln. Open this plugin, go to source, and public. We will take this ocean FFT calculator and this buoyancy component. Copy these three files and pass it here. And we don't need this ocean water zone because we don't use water zone from the water system anymore. Copy this and paste it to CPP. And let's generate Visual Studio project files. Open ocean-tutorial.sln. And go to plugin, the source. Because the source, we copy this file inside this plugin, so we need to delete this too. Close it back, go to source, delete all the file inside this public and the private. Delete this intermediate and save, delete, generate. You can open this plugin, public, go to WaterMesh actor.h. Wait for our Visual Studio to find the error and save it to speed up this process. Include ocean FFT calculator .h, and we add the variable is focean FFT calculator. FFT calculator. And save. And we go to watermeshactor.cpp. In this watermesh actor, after we set the water mesh, we initialize the FFT calculator. Initialize. In event tick, called FFT calculator and calculate get word. FFT calculator show debug displacement points, get word, and get actor location, and save. We use this instead of initialize it inside the water zone. Go to my buoyancy component.h, and we don't include this ocean water zone. We include WaterMesh actor.h, and this ocean water zone, change it to a WaterMesh actor. And change the name to WaterMesh actor. And this API is custom water because this is custom water plugin. Let's save this and go to my buoyancy component.cpp. We have to include this first before we include other header file, and delete this and go to the error, this a ocean water zone, change it to a WaterMesh actor. WaterMesh actor. A WaterMesh actor. And if WaterMesh actor we return the FFT calculator. And save. And we go to other file. See if there are any error. Oh, it is correct. Let's try play this. We can open the project, but our buoyancy component, we're missing the last buoyancy, so open this boat blueprint. And add my buoyancy, compile and get my buoyancy, set my static mesh component, make it to my static mesh component, and get my buoyancy, set pontoon locations, and set it to the array. Compile and save. And another one, we have bad blueprint because it have the error. Add my buoyancy, compile and get my buoyancy, set pontoon locations, set it to these pontoon locations, list, get my buoyancy, set my static mesh component, and static mesh, compile, and it fix all the error. Let's save all. Let's play test. It is not working. It's not working because we need to add this water mesh actor, because the FFT calculator is inside this water mesh actor. So let's add it into the scene, set it to 0, and here it's working again, the buoyancy. Let's see our wireframe, this wireframe mode. And you can see this plane is a really high poly plane that we cannot scale it to the large scale. We need this tessellation to optimize this. You can delete this. And for the water material, let's go to ocean water material and this water material. And we need to set it use with water to use with this tessellation mesh. And save. And you can duplicate this and name it to ocean water BG. You can simplify this material to use as the background of the water. And let's go to water mesh actor and set water material to this. And file mesh, we set to this material and we not yet use file mesh. Let's test this first. Let's play test. Now we have the water mesh actor. And to see the wireframe mode, copy this, or you can type all.water_watermesh.show wireframe1 and pass it into this command, and you can see this mesh and it have a working tessellation depending on the camera location. And you can set this tessellation factor lower or higher according to your target hardware. But if it's set higher, it's look better. To disable this, can set back to 0. And let's see the file mesh. Use file mesh and enable. You can see this have the file mesh. You can multiply this file mesh by 50 and multiply this center mesh extend to 50. And here we have a really large file mesh. See the wireframe again. It's working correctly. So we achieve what we plan to do for this tessellation. So to review our plugin, this tessellation created by using the custom vertex factory that store the information inside the water quad tree and create the water mesh scene proxy, and then this water mesh component, and after that it is water mesh actor. That is the actor that we can put inside our scene. If you would like to know more about this custom mesh component, you can read this blog that give you more insight about this, how to create this custom component, and you will know more what is vertex shader and vertex factory. This is the end of our tutorial. If you have any question, please leave it in the comment section below, and if you like this tutorial, please subscribe to my YouTube channel. Thank you for my patrons member who are supporting me. Your support really means a lot to me, and you made this possible. Thank you very much, and see you in the next tutorial.